Have you ever stared into the night sky and wondered what it would be like to travel to the stars? To journey beyond our solar system? To cross the vast interstellar void? To step foot on alien worlds orbiting distant suns? This is the dream of interstellar travel, a dream that has captured the human imagination for millennia and continues to do so today. But along with the dream comes the reality. Interstellar travel is no simple task. It's a concept that's as complex and mysterious as the universe itself. And the first mystery we encounter is the sheer scale of the cosmos. Space, as it turns out, is incredibly vast. The distances between stars are so immense that they boggle the mind. For instance, our closest stellar neighbor, Proxima Centauri, is more than 4 light-years away. That means even if we could travel at the speed of light, it would still take us over 4 years to get there. And the speed of light isn't just any speed, it's the ultimate speed limit of the universe, a limit that no object with mass can reach, let alone exceed. But let's not be disheartened. After all, we humans are a species of problem solvers. We've always found ways to overcome obstacles and push the boundaries of what's possible, and so the dream of interstellar travel remains alive. Scientists and engineers around the world are working on innovative propulsion methods, like antimatter engines and warp drives, in hopes of one day making this dream a reality. Yet these potential solutions bring with them their own sets of challenges and unknowns. And then there's the deep space environment itself, a realm of cosmic radiation, microgravity, and extreme temperatures. A realm so alien and hostile to life as we know it that we can only begin to imagine the challenges it poses to interstellar voyagers. So let's dive into the cosmos and unravel the top 10 mysteries of interstellar travel. The speed of light, a cosmic speed limit that seems unbreakable. It's a boundary that's been around since the dawn of the universe, an ultimate rule set by none other than Albert Einstein himself in his theory of relativity. This theory fundamentally states that nothing can travel faster than light. Now, light zips along at a staggering 670 million miles per hour. That's pretty brisk, right? But when we start talking about traveling among the stars, suddenly, it doesn't seem so fast. Let's take our closest stellar neighbor, Proxima Centauri, for example. It's over 4 light-years away. Even at the speed of light, a journey there would take us over 4 years. That's a long time to be cooped up in a spaceship, isn't it? It quickly becomes clear that the speed of light, while incredibly fast, poses a significant challenge for interstellar travel. But what if we could somehow bypass this cosmic speed limit? Warp drives, a concept straight out of science fiction, but could they be our ticket to the stars? Imagine a spacecraft that doesn't travel through space, but rather bends space around itself. This is the essence of a warp drive, an idea that has captivated scientists and dreamers alike. In theory, warp drives could allow us to traverse vast cosmic distances in the blink of an eye, effectively bypassing the pesky speed of light limit. The concept hinges on Einstein's theory of general relativity, which allows for the warping of space-time. By creating a bubble of flat space-time around a spacecraft and contracting space in front while expanding it behind, the ship could move faster than light, on a space-time wave, so to speak. However, creating this space-time bubble requires exotic matter with negative energy, a substance that remains purely hypothetical. Yet even with warp drives, other challenges lurk in the depths of space. Space isn't empty, and that's a problem. As we delve into the mysteries of interstellar travel, we encounter the challenges of the interstellar medium. Picture this, a sea of cosmic dust and gas that fills the space between the stars. This isn't your typical vacuum, but a vast, unpredictable expanse that could pose significant threats to any spacecraft daring enough to venture through it. Imagine a vehicle speeding down a highway at incredible speeds. Now imagine that highway is filled with unpredictable debris from pebbles to boulders. This is the reality of a spacecraft traveling through the interstellar medium, where even the tiniest speck of dust can cause calamitous damage at high speeds. And it's not just dust we're worried about. The interstellar medium is also home to cosmic rays, high-energy particles that can wreak havoc on a spacecraft's electronics. So, while space might seem like a smooth, empty highway, it's more akin to a treacherous mountain road at night. From dust to radiation, space is far from a smooth ride. cosmic radiation, an invisible threat lurking in the depths of space. This danger is not one to be taken lightly. Born from the fury of distant stars and cataclysmic cosmic events, these high-energy particles permeate the universe, creating a hazardous soup for any travelers brave enough to venture into the cosmos. These particles, traveling at near the speed of light, can wreak havoc on both electronic systems and biological tissues. For our spacecraft, this means potential damage to onboard systems, rendering them inoperative. For our astronauts, the stakes are even higher. Extended exposure to cosmic radiation can lead to serious health issues, such as cancer and other radiation sicknesses. As we continue our journey into the cosmos, finding ways to shield against this invisible enemy will be crucial. From spacecraft design to astronaut health, the impact of cosmic radiation is a challenge we must face head-on. Radiation is just one of the many hazards we must overcome. What if we're not alone in the universe? As we journey beyond our solar system, this question becomes increasingly pertinent. The cosmos is vast, teeming with countless galaxies, stars, and planets, and it's potentially ripe for life as we know it, or perhaps life as we don't know it. Consider this. Our understanding of life is based on a single sample, Earth. What if life elsewhere doesn't play by our rules? What if it's not carbon-based or doesn't require water? The potential diversity of life in the universe is mind-boggling and could present unforeseen challenges to interstellar travelers. And what about intelligent life? Encountering an advanced civilization could lead to astonishing advancements in knowledge and technology, but it could also pose risks. What if they're not friendly? What if our definitions of friendliness don't align? Alien life, a thrilling yet daunting prospect. The mysteries of the universe are vast and varied, and as we reach for the stars, we must prepare for all possibilities. Time is relative, especially when you're traveling close to the speed of light. Now, this isn't just a catchy phrase from a science fiction novel. It's an actual phenomenon predicted by Einstein's theory of relativity, known as time dilation. But what does it mean, and how does it impact our dreams of interstellar travel? In the simplest terms, time dilation means that time can appear to move slower for an object in motion compared to an object at rest. So if you were aboard a spaceship traveling close to the speed of light, time for you would pass slower than it would for someone back on Earth. It's a bit like the universe's version of a slow-motion replay, but it's not just about the cool factor. Time dilation has some serious implications for interstellar travel. Imagine you're an astronaut embarking on a journey to a star system 4 light-years away. Traveling at near-light speeds, you might experience the trip as taking just a few years. But back on Earth, decades could pass. By the time you return, you might find a world that's moved on without you. It's like a time machine, but only in one direction. This poses a unique challenge for interstellar travel. How do we reconcile the human lifespan with the vast timescales of the cosmos? How do we maintain connections with home when every trip could span generations? These are questions we're still grappling with. Moreover, the effects of time dilation aren't just theoretical. They've been confirmed by experiments like the one where atomic clocks flown around the Earth came back showing a different time than their stationary counterparts. It's a reminder that the rules of the universe can bend in ways that seem counterintuitive to our everyday experiences. In the end, time dilation is more than just a curiosity. It's a fundamental part of our universe, a reminder of the strange and wonderful rules that govern reality. It's a hurdle we'll need to navigate if we ever hope to travel among the stars. Time dilation, a mind-bending consequence of traveling the stars. Interstellar travel demands an astronomical amount of energy. Truly, the sheer quantity of power required to traverse the vast cosmic distances is mind-boggling. To give you an idea, even our most efficient rockets, if they were to travel to the nearest star, Proxima Centauri, it would take over 70,000 years. So how do we solve this energy problem? One potential solution lies in antimatter propulsion. Antimatter, the mirror image of normal matter, when it comes into contact with its normal counterpart, annihilates, releasing immense energy. This energy could theoretically be harnessed to propel a spacecraft at a significant fraction of the speed of light. Of course, creating, storing, and using antimatter is riddled with its own set of challenges, but the promise it holds is too great to ignore. We might be decades or even centuries away from realizing this technology, but it remains a tantalizing prospect. In the end, it all boils down to energy, the fuel of interstellar journeys. Space, the final frontier. But what unknowns await us? As we gaze into the cosmos, we're acutely aware that our knowledge about what's out there is dwarfed by what we don't know. The vastness of space, with its innumerable galaxies and uncharted territories, presents a daunting challenge for interstellar travel. What if we encounter phenomena that our current science can't explain? What if there are forces or entities beyond our understanding? The potential for unexpected challenges and discoveries is as infinite as space itself. Just imagine we could stumble upon a wormhole that alters our perception of time and space, or discover an exotic form of matter that reshapes our understanding of physics. We could even encounter civilizations far more advanced than ours. These unknown unknowns, the mysteries we aren't even aware of yet, are the most thrilling and terrifying aspects of venturing into deep space. The unknown, the ultimate mystery of interstellar travel. Once we reach the stars, how do we get back? This question is a mystery that's as intriguing as the interstellar journey itself. The challenge of returning from a distant star system is no less than the initial voyage. Consider this. We've journeyed thousands of light years, overcoming obstacles like the speed of light conundrum and the energy problem. We've navigated through the interstellar medium, shielded ourselves from cosmic radiation, and maybe even encountered alien life. But now, we face the return trip. The same challenges present themselves, but this time we're far from home, with resources potentially depleted, and our understanding of Earth perhaps outdated due to time dilation. The propulsion systems we use to get there, whether it's antimatter or warp drives, need to be reliable enough for a round trip. And let's not forget the unknown unknowns, the unexpected challenges that we can't predict or prepare for, the return journey, a challenge just as daunting as the journey out. At the heart of interstellar travel lies the most complex element, us. We've tackled the speed of light, warp drives, cosmic radiation, and even the unknown unknowns. But the ultimate mystery of interstellar travel is not just about the vastness of the cosmos or the technical challenges we face. It's about the human beings undertaking these journeys. The human body is a marvel, designed for life on Earth. But space? That's a different story. The harsh realities of space travel can have profound effects on the human body. Microgravity can lead to muscle and bone loss. Cosmic radiation can increase the risk of cancer. And then there's the isolation. Imagine being confined to a small space, thousands of light years away from Earth, with no immediate chance of return. The psychological toll can be immense, leading to issues like depression, anxiety, and other mental health challenges. And let's not forget about the potential for disease. In the closed environment of a spaceship, even a common cold could have serious consequences. Plus, we don't yet know how space travel could affect our immune system in the long term. We're also faced with the question of time. Interstellar travel would take years, if not decades or centuries. How can a human endure such a journey? Could we use hibernation or stasis technology to preserve the human body during these long voyages? These are questions we are still grappling with, but we're not just problem identifiers. We're problem solvers too. We're studying the effects of space on the human body, developing new technologies to protect astronauts, and even looking at ways to support mental health during long-duration space missions. This is the human element of interstellar travel. It's not just about getting to the stars. It's about understanding and overcoming the challenges we, as humans, face in doing so. It's about asking ourselves, can we endure? Can we adapt? Can we thrive? The human element, the final and perhaps greatest mystery of interstellar travel. The mysteries of interstellar travel are vast, but so too is our ambition to explore the cosmos. We have journeyed through a universe of enigmas, from the speed of light conundrum to the unknown unknowns of deep space. We've delved into the potential of warp drives and antimatter propulsion, the hazards of cosmic radiation and the interstellar medium, and the philosophical and practical challenges of time dilation, energy consumption, alien life, and the human element. But these mysteries do not deter us. They inspire us. They fuel the fires of our curiosity and push the boundaries of our knowledge. With ongoing research and technological advancement, we are slowly but surely finding answers. We are learning to navigate the vast and complex tapestry that is our universe. As we stand on the brink of the interstellar age, we continue to dream, explore, and unravel the mysteries of the cosmos. As we conclude our journey through the mysteries of interstellar travel, we'd like to remind you that the universe is not just out there, it's within us all. The same curiosity that drives us to explore the cosmos also fuels our thirst for knowledge here on Earth. If this video sparked new ideas or answered questions you've pondered, we'd love to hear about it. Your engagement helps us create more content that intrigues, educates, and inspires. So, please don't hesitate to hit the like button if you've learned something new today. Share your thoughts, theories, or further queries in the comments section below. We're always excited to see the discussions that our content sparks. And remember, each one of us is a part of this grand cosmic story, so don't forget to share this video with your friends and family and bring them along on this interstellar journey. Finally, if you haven't done so already, make sure to subscribe to our channel and press the bell icon. This will ensure you don't miss any of our future explorations into the vast and fascinating universe that surrounds us. Thank you for joining us on this journey. Until next time, keep looking up, keep wondering, and keep exploring.